Hello everyone, welcome to Sci-Ease. Now, in last video, I discussed about the saturated and unsaturated hydrocarbons, that is alkanes, alkenes, and alkynes. In continuation to that, I want to tell you one very important term, that is homologous series. So in this video, I will tell you in detail about the homologous series of alkanes, alkenes, and alkynes. What is homologous series first? A homologous series is a group of organic compounds having similar structures and similar chemical properties in which the successive compounds differ by CH2 group. First, we will take the homologous series of alkanes. Up to pentane, I will take methane CH4, ethane C2H6, propane C3CH8, butane C4H10, pentane C5H12. You can see that there is difference of CH2 group between two adjacent members of the series. Methane and ethane, there is difference of CH2. In the same way, ethane and propane, again CH2, propane and butane, CH2, and butane and pentane, again CH2. So there are some common criteria for the homologous series. First thing is that the general formula that should be same. So here the general formula is, I have already told you, CnH2n plus 2. First thing is that the general formula that should be same. Second is, there should be difference of one carbon atom and two hydrogen atoms in the series between the two adjacent members of the same series. Third, the difference in the molecular masses between the two adjacent members, that should be 14U. How it comes? CH2 is the difference, 12 for C and 2 for molecular mass for two hydrogens. So the difference of 14U, that should be there. Next point is that they should have the same chemical properties. And last one, that there is gradual increase in the physical properties of this members as the molecular mass that increases. So by taking this homologous series of alkanes, the things have become clear to all of you that there is difference of CH2 group between two adjacent members. Molecular mass, that is 14U, that should be the difference between the two adjacent members. Difference of one carbon and two hydrogens should be there. Now you can take the case of homologous series of alkenes. First, you will write the general formula, that is CnH2n, as I have already told you. Now the first member, that is ethene, it will have C2H4. Propene, the difference between ethene and propene, again there is difference of one carbon and two hydrogen, that is CH2. In the same way, you can see that between butene and pentene, there is difference of CH2. Between pentene and hexene, there is difference of CH2, and the molecular mass, how much difference? That is of 14U. In the same way, you can take the case of homologous series of alkynes. First thing I have told you that this series that should have the same general formula. So alkynes, they are having the general formula CnH2n minus 2. So ethyne, it will have the molecular formula C2H2, propyne C3H4. So there is difference of again CH2 here between the two members. So you can see between propyne and butane, again difference of CH2, butane and pentane, difference of CH2, pentane and hexane, difference of CH2. So this is the homologous series of the hydrocarbons, alkanes, alkenes and alkynes. I have discussed this. Now, I want to tell you here that organic compounds such as haloalkanes, alcohols, aldehydes, ketones and carboxylic acid, they also form the homologous series. But that I will tell you first about the functional group and the suffix used for that functional group, and then I will tell you the homologous series. For that, I will discuss it later on. Now, thank you.